Let's see some examples of derivatives of inverse trig functions. Now that we've learned all the derivative rules, we can apply them. Remember that the first question is always what type of function we're working with. So if we have y equals sine inverse of x squared plus 5, starting with something very simple. When we ask what type of function, the answer is it's inverse trig function, particularly inverse sine. So we know that when we say inverse sine, then everything depends on this u of x, this function of x. So once you determine what u is and understanding that this is a sine inverse function, then the solution becomes very easy because we have the formula. So we know that derivative, either you say y prime or you say dy over dx, which is derivative with respect to the variable x. Then we know that by formula we have u prime divided by square root of 1 minus u squared. So you see that everything depends on what u is. That's why it's so important to mark it here and understand it. So now you can either set it up, or if you feel very comfortable with the derivative rules, you can just apply it and find derivative of x squared plus 5. I do the first example step by step, so I'll show you how I set it up, and then I'll show you more examples where we just go to the derivative. So here's 1 minus, and then u squared, so replacing u with x squared plus 5. Then the last part that is left is finding this derivative of x squared plus 5 in the numerator. We know that derivative of x squared plus 5, that's a sum function. Therefore, we need to find derivative of each term. Derivative of x squared, again, we ask what type of function is x squared, and that's power. So derivative of x squared is 2x. Plus derivative of 5, 5 is a constant, so derivative is 0. And that's it. Denominator, you just rewrite it. And that's derivative of the function sine inverse of x squared plus 5. Okay, let's look at another example. Let's say we have y equals cotangent inverse of 8 to the x. Okay, first question, what type of function? And we know the answer. This is inverse trig function, particularly inverse cotangent function. So as soon as we say inverse trig function, we know that everything depends on this part u of x. So y prime or dy over dx, by formula, we know that numerator of all of them is u prime. This is cotangent inverse, so numerator also has a negative. And then in the denominator, we have 1 plus u squared, similar to tangent inverse of u. Okay, now, since we know what u is, we already marked it, so I'm going to replace every u that I see by 8 to the x. Okay, another thing that is left is finding derivative of 8 to the x in the numerator. So I rewrite the negative. Now, the question is, what type of function is 8 to the x? We see that this is an exponential function, and we know that derivative of exponential is write the same, multiplied by ln of the base, multiplied by derivative of the exponent, but in this case, exponent is just x, so it's not chain rule, it's just applying the exponential, very simple. So repeat the function, multiply by ln of 8, natural log of 8. And even if I say multiply by derivative of the exponent, exponent is x, so derivative of x is 1. Over. Now in the numerator, we can write 1 plus 8 raised to 2x, because you have double exponent here, which means you multiply them. Let's look at another example. Y equals secant inverse of 3 sine x. Okay, question is what type of function, and we see that it's inverse trig function. Okay, as soon as we say inverse trig, then we mark which part is u of x because we know that our focus is on that part. So then y prime, or derivative of y with respect to x, is, first I'm going to set it up. So formula says in the numerator we have derivative of u with respect to x. In the denominator we have absolute value of u multiplied by square root of u squared minus 1. Okay, now that we know this part and we know what u is, the rest is by substitution. So in the numerator, 3 sine x instead of u, and we have to come back to this part because we still need to find the derivative of it. In the denominator, absolute value of 3 sine x square root of 3 sine x squared minus 1. Okay, now derivative of 3 sine x in the numerator, we have to work on that. What type of function is 3 sine x? We know that 3 is the constant multiple, so we just write it down. And then sine x is a trigonometric function, so it's derivative of sine, which is cosine of the same angle x. And then everything in the denominator repeats. Okay, so here you see that instead of 3 sine x squared, I'm writing 9 sine squared of x, which is equivalent to what we have. So here are a few examples. I hope that by now you see that whenever there is an inverse trig function involved, we need to mark which part is u, and then we write the formula, substitute everything that u, wherever you see u, and then find derivative of u in the numerator for each one.